We all have a story to tell. Let's tell yours. Welcome to the Intellectual People Podcast with your host, Jason. Come together and listen to journey stories and more from interesting people. Welcome your host, Jason.
Welcome to the Intellectual People Podcast. I often post on forums, and I'd like to personally thank those forum owners for allowing me to post on those forums. In no particular order, they are audiosciencereview.com, audiocircle.com, audioshark.org, audiofilestyle.com, AV Nirvana, which is also the home of Room EQ Wizard and AudioLens, DIYaudio.com, gears.com, and Parts Express Forum. Thank you so much and enjoy. Welcome. I have Galen Gareis on the show today. How are you doing today, Galen?
Just fine.
Great. It's really nice to have you. You're my first cable designer here.
Well, thank you.
Galen, take me back to how you got into cable design, because I'm sure as a little boy you didn't say one day, I want to design cables for a living. So take me back to your childhood and kind of walk me through, if you would, how you ultimately got into cable design.
Well, nobody does this job on purpose. It's kind of like the garbage man. When you do a great job, everybody's happy, but nobody notices who's doing the work. So it's really kind of a thankless engineering job. You don't get much notoriety when your Ethernet works or what have you. But when I got out of school, obviously you're through a college, you're supposed to go get a job. So I went to all the usual places that you would think you'd get a job, Intel, Sperry Univac, so on and so forth. But it was during a recessionary time, if you recall, back in the early 80s, late 70s. And I saw a little postage stamp size blurb in 6-point font, cheapest ad you could get, in the Exponent, pinned to the wall in the engineering office, that said they were looking for, quote, design engineers.
Okay.
And I looked at that and I thought, well, I don't know. I guess that's a job. I don't know what making cable or working for Belden's all about. That sounds kind of weird, but I'll go ahead and go there. Just, try anything. Well, I went. I ended up getting the job. So I told my dad, well, now what? I don't know anything about RF cable design. So Bob Cole, who was the boss at the time, said, you don't need to know anything. Here's this book. He gave me this book that's about 4 inches thick and plops it down in front of me, because that was in a day of paper, and said, here's what you need to know about cable. You start tomorrow, and when you have trouble, just the answer's in here. So it was basically sink or swim.
Gotcha.
The fundamentals were there, mind you, but in terms of how do you make the cable, in the day, we didn't have cubicles. Our desks we faced each other in desks. So I faced a senior engineer. So if I had troubles, I had to just look up and look right at Ken's face and say, Ken,
right,
what do I do with this dielectric on this machine? And he would tell me. So that's how we worked. And it was actually worked really, really well, because you could it didn't take him that much time to answer my question, which I had a lot of, but it didn't slow him down much either. So that's how I ended up designing cable, is you jump in the pool and you make it to the other side, or you sink, basically.
Are you an electrical engineer then?
I'm what they call electrical engineering technology. It's not pure math like double E. Those would be the guys that like masks for integrated circuits, and things like that. In other words, they do everything in calculation. And then, of course, technologists take the calculations and apply them to the real world. So I'm kind of in between those two. So a double E can do things on paper, which obviously you've seen the papers. But right. I also go to the plant floor, and I have to actually make it into a real product that works. So at Belden, they kind of require people that can do both things and are comfortable, with figuring out what went wrong or what didn't.
Sure. Are you still employed by Belden today?
No, I actually retired and took the Iconoclast cable line, and now I'm work under Blue Jeans Cable. I was under Belden for 35 years, but technically I'm a customer of theirs now, believe it or not.
What level at Belden did you have? What did you wind up retiring, I presume, from Belden as?
Yeah, it's like most companies. The longer you're there, the bigger the title they give you. So I guess you find yourself important. But they called me principal product engineer. But that's just a name they give to someone that's been around for 25 plus years. I understand. I don't place much merit in titles, but that's what I was called, principal product engineer.
What products were you responsible for designing there?
It's easier to say what I wasn't, like portable cordage per se, but through the years, I worked in all product disciplines. They moved the engineers around on purpose because the expertise tends to overlap, but it only overlaps. So there's areas that don't, and they want people that are well-rounded. So if someone's missing or you have to be called to the plant floor because you have one engineer and two plants to go to, they can send somebody else. So Belden's pretty good about trying to make sure that over the years, everybody gets a little bit of fiber optics, a little bit of RF coax, a little bit of Ethernet cables, so on and so forth. So did a little of everything.
Did you have a hand in developing Ethernet cable?
Oh my gosh, yeah. DT600E, and I have a patent on that product. That's probably one of the best Ethernet cable that has actually ever been designed. To this day, it still is.
Is it safe to say that there's billions of Ethernet cable in this world? Billions of miles, I'm sorry.
Oh my, yeah, it's unbelievable how much. Yeah, the world's run by Ethernet, no question about it.
And is it also safe to say that Ethernet cable has to be very robust because it's not a cable that is commonly replaced, right? The whole idea is to install it for 30, 40 years and not touch it. Would that be accurate?
Oh, yeah. No question. It's like plain old telephone system cable, which people think of as old-fashioned, but it was made to do the job it does, and it still does it today. So, right. Yeah, it still works fine.
So you can say accurately that you had a hand in developing nearly all Belden cables.
Yeah. I mean, all kinds from fiber optics, you name it. Now I was in fiber optics, for probably about 10 years. And then I was in Ethernet. And prior to that, I was in what's called instrument cables and what's called the generic product line. And the generic product line, we only call it that because there's not enough of one particular product to call it a product line, but there's still a lot of cables. So that's a lot of different kind of instrumentation cables. If you look at our catalog, it's got literally thousands of items in it, for instance. So the guy that's actually in the generic side has more on his plate than the guy who's on the Ethernet cable side, believe it or not, because he has a more variety of types of products and, of course, different requirements and what have you. So you learn a lot when they put you under the generic product line. And you don't want to screw them up either, because those products have been there for a long, long, long time, and the customers are expecting them to work in a particular way. So as you do drop moves and changes due to compound improvements and all of that, you need to make sure that the form fit function, so to speak, doesn't change. And that's a lot harder to do when you got a lot of different cables.
Sure. What type of testing standards does a company like Belden have?
Well, you got the mil specs. Okay. UL is more of a safety agency. I know people think of it as a testing standard, but they aren't. They'll test to a standard that you bring them. For instance, if you go there with an Ethernet cable, they'll test at the TIA, EIA standards for you as a third-party tester, but they themselves don't come up with the test. They aren't IEEE either, which come up with the computer standards for cable and all of those kinds of things. So a lot of people confuse what UL does, or even, the various other ETL standards agencies. So,
do you believe that a UL standard is important?
Oh yeah, my gosh. People will try to cheat whenever they can making these products, and sometimes they can be catastrophically dangerous. So having a third-party viewpoint on whether you're hitting your target is definitely required. Yeah.
Can you explain to the listeners in layman's terms what UL actually does and how they do it?
Yeah. For instance, on Ethernet cable, depending on the amount of product you make, they will require a sample every so many hundreds of thousands of feet that will be pulled out randomly by a UL inspector. In other words, they'll pick their own sample and they'll test it to all the requirements called a UL evaluation report, or UL, test report. And they'll test the cable for every single parameter that it's supposed to meet using your equipment in your plant. And if they feel that there's something in error or a miss, they'll actually take that exact same sample and they'll retest it at their facility to round robin to make sure that if there's a disagreement that it's, uncovered, or, hey, what's wrong kind of a thing. Only then will you get the UL certification on the product. And if you fail, they will actually make you go back in and go backwards and figure out where the problem occurred, and that product can't be sold. And then you have to put in corrective action and fix it. So there's a lot of pressure to make, when the UL inspector basically finds a problem, you already have a big problem because you've made a lot of cable. All right. So there's an impetus when you're under a UL verified program, is what it's called. It'll actually be printed on the jacket, UL verified, Cat 5e, Cat 6, what have you, because it is. And you can't sell it unless it's UL verified. But again, they don't make up what to test. They verify what the test is. So TIA, EIA puts out the document, what you need to meet. UL will take that document and test to it as an independent third-party test agency. Another company is ETL, Independent Test Laboratories. They're like a UL, but just another organization that does the same thing. So there are other people out there. In Europe, they have what's called Delta and 3P Labs. So there are other organizations that'll do third-party verification tests.
Great, thank you. Does that also exist for low voltage and high voltage?
Oh yeah, you have AWM styles, appliance wiring material, all kinds of various UL styles. And of course you have the mil specs that you need to test to and what have you as well. So you have what are called QPL, qualified producer list materials. Those have to be independently inspected and verified for the military programs. Now you can have a lot of cables that are mil C17, blah, blah, blah type, which means there's some kind of a modification to it. It's not really a mil spec cable. Right. So don't think when you buy a type cable, it really meets the same standards as a full-blown mil spec cable.
While you were at Belden, did you often get requests from audio manufacturers for wire?
We did, and how we generally handled it is we would say, give us the specs that we know we can test to verify you're getting what you want. Because we can't make cables to adjectives. We can only make it to actual test data. So as long as what you want us to test to is legitimate, we'll make the product. But the minute you go outside of the realm of realistic development and testing, we're not going to put our name on it or have it sourced from the plant. So they were very strict about that at Belden, that you had to have a document that said what it really is in reality, whether you liked it or not. So,
and were the requirements the way the wire was twisted or material, or can you give me an example of the common request?
Well, it'd be something like capacitance, inductance, resistance, cap unbalance. You might do shield effectiveness evaluation testing where you need a certain amount of emissivity for the shield. You might do transfer impedance, which is a way to generate the impedance of the shield as far as RF noise is concerned. You might have a balance test. Common mode rejection ratio, for instance, is a type of a balance test. You might have an I pattern test with a digital signal put on the cable. There's all types of real world tests you can do to a cable that says, okay, this thing is meeting the metrics of what they want. And better, we can determine if we keep making it the same way every day so the cable doesn't change.
Do you believe there's a correlation between those metrics and the good old-fashioned audiophile golden ears?
That's a tough one. At some point, these cables can't good enough to where someone can't hear it. There's no doubt about that. It has to be the case. It's just like capitalism. All trees don't grow to the sky. Sooner or later, the party's going to end, right? You know it. Likewise with cable. Now, what Iconoclast was designed to find out is, okay, we got what we call our standard Belden products, 1313A, 1694A. In other words, our products we sell every day. What would happen if you tried to make those products as good as you possibly could with everything you know to be legitimate and do it internally to Belden so you don't get involved in the politics and the feelings of the industry that you're kind of attacking in a way? If you make a cable like that and you test it for the known standards, can you hear a difference in the system? Is there anything left on the table that someone would feel it's worth, buying? And that's what Iconoclast was meant to do, is kind of prove whether you could hear it or not, even if the cable's better, because they get to change the cabling. I know the cable's better, or else why do the experiment, right? If I work like crazy and the cable tests the same as the old cable, there's nothing there that you could possibly hear, right? It's the same. So I had to make a cable that I know is better. And when I got it sufficiently better to where I think that, hey, this is good enough where I'll be able to tell the difference, do we? So that was kind of what brought the whole project up.
How did you get aligned with Blue Jeans Cables, who now owns Iconoclast Cable, correct?
They don't really own it. The 3 patents are actually owned by Belden. They're actually my patents, but Belden owns, the patents developed by myself. They are licensed, so to speak, to manufacture the assemblies and sell them by Belden. Okay. So that's the correct way to look at the relationship.
How many patents do you have?
30 something. I don't know. Somewhere in there.
Was this patent a newer one or an older one?
The 3 patents are relatively new because I took technology from a wide subject area to develop all 3 of the products. All 3 products are actually patented. So,
is Belden proud of these patents because they use them elsewhere, or is this pretty much just licensed to Blue Jeans cables, Iconoclast cable, and that's it?
Normally when a company develops things, let's say you might develop 3 or 4 or 5 different patents, but only one is applicable to the markets they think they can be effective in. So some of the patents were used for what we call the BAV product line, Belden Audio Video product line, and that's a very high performance balanced XLR cable. And that was, they told me, I said, okay, of all the stuff you've done here, this is what we think our market, our core market is the pro recording studio market. If they want an exemplary quality XLR cable, this would be the kind of product we're interested. Can you make Iconoclast into that kind of a product? And I said, yeah, more than likely. So I did. I turned it into a high performance pro XLR product. The pro market doesn't use speaker cables because they use XLR's 2 powered speakers. They don't use RCA because they normally use balance. So those 2 products kind of slid off the end of the table, but they were still a requirement for the project in and of itself. So, and that's typical of a lot of companies is they'll look at what's been done and say, okay, this right here that came out of this is good. And I'll tell you something, in the professional world, 1 out of 3 ain't bad. A lot of times you won't get 1 out of 10. So from that viewpoint, the product was quite successful in terms of what it taught in Belden.
How did the marriage of you and Iconoclast Blue Jeans come about?
Well, I developed Ethernet cables for probably about the last 10 years of my career, and I knew Kurt Denke personally because we designed and manufactured cable for Kurt. And he had some special type products that we made just for his market, for instance, that were more suited for the home market versus a professional market, or what we call the IT market. So I knew Kurt for years. So there was a shoe-in to really say, hey, Kurt, Belden has this product line. You don't want to do it. They don't know what to do with it because they don't serve a small hobbyist type market well. They tried, but their system just doesn't work. And they're like, Galen, we can't, it's too expensive for us to service this based on the cost of doing it within this big giant company. So what I did is I said, I'll tell you what, I'm close to retirement. I'll tell you what, I'll retire. I'll take the product line. I'll go to Kurt and we'll manufacture the assembly and you can make the cable and I'll basically work with you as a customer. And they said, well, that would work perfect in terms of how you could bring that product to market, because Blue Jeans is specifically there for the hobbyist type market. They're not there for IT or the big professional markets.
Right.
Not so much.
What would be the difference between a professional grade and a consumer grade Ethernet cable?
What the difference is, one guy owns 70,000 assemblies and another guy orders 1. That's the difference.
Okay.
It's just the
so
volume.
The cable itself, its volume, it's not the cable itself is different.
There might be some minor changes in the cable, like jacket printing, that has something on it that the consumer market wants to see that the professional market can give a hoot about. They just care about the UL and it's verified. The consumer market may want to know the bandwidth of the product, things like that, because they're not as informed as the pro market. So some of the printing and ID on the cable may be a little bit different. Even the color of the jacket might vary. The pro market's interested in black as black, because it's cheapest and it's not UV sensitive, and they're going to put the cable in for years. The consumer market might want a pink cable, and you say, well, pink's kind of light color. It's not going to be as color fast as black, and you might have to replace it if it's in the sun for 10 years because it might age more and get brittle and crack. But they're going to say, well, I'm only going to use this cable for 2 years and get another one that's light blue anyway. So again, the consumer market doesn't have the demand sometimes that the pro market does. So
understood. But the construction and the design of the cable is indeed the same.
Physics don't care who's using it. So that pretty much sticks. Yeah.
Okay, great. You go with Kurt to Blue Jeans Cable and you create Iconoclast cable, correct?
No, I created Iconoclast cable before Blue Jeans.
Right, but to market,
But to market, we went through Blue Jeans. They buy the bulk cable and they manufacture it into assemblies, which is a labor-intensive as the Dickens process, let me tell you, because I was doing it in my basement myself for quite some time during development. So making cables into assembly is no easy feat when you've got 24 wires per polarity times 4 polarities. And, you're working with all that. And then you have the interconnect and the XLR cables that have 4 30 gauges times 4 conductors. So it's fine detail work. These cables were made, remember, to test extremely well, not to be easy to terminate. That was the last objective. And unfortunately for the mass market, termination is probably, if not one on the list, at least number 2. On Iconoclast, it wasn't even on the list. The only thing that was on the list is, could they be terminated at all to test and evaluate, to prove whether truly better cables could conceivably, sound different in an application. So if I could get a connector on it, the design was feasible to make. So
what was Iconoclast cable originally designed for then?
It was designed to prove the point that either A, our current offerings were good enough, or B, they weren't. And there was a step up that people may be willing to pay for given the proper application. For instance, we buy coaxial cable that go to an S parameter test unit, okay? And it has to be a super high precision cable, at least 10x better than what you're testing. Those assemblies, we don't even make at Belden, believe it or not. We have them specially made and tested by Hewlett Packard. And those assemblies, for instance, can be $3,000 a set or more. That's an example of a very isolated place where a customer is going to say, yeah, I need 30 dB or better return loss cable versus 23 dB, because I can't test 23 dB production cable unless I'm several orders magnitude better than that, or I'm not testing anything. I'm testing my test equipment. So there are markets for really, really good cable, even though most people will say, well, 23 dB, that's almost nothing. Well, you're right, but that's why we have to have a cable that's nothing times nothing. So better cables do exist. A lot of people will draw the line in the sand and say, well, this level of RLNC is good enough. For most people, that's an appropriate answer. But we wanted to find the answer, period, that, hey, if you do make better RLNC, is it applicable in a high-end audio system? So let's try it. Let's see what happens.
How did you test those cables to quantify that they are indeed better for an audio system?
Well, 2 ways. You look at all the attributes that will affect, theoretically, analog transmission. There is skin depth at 20 kilohertz. There's definitely skin depth characteristics. There's definitely proximity effects that can be calculated through the audio band. There's definitely RLNC. There's definitely velocity of propagation differential problems called group delay through the audio band, primarily because your velocity of the signals going through the cable at RF are constant. But as you go down to DC, DC in theory has 0% VP. DC is always there. It's not moving in the cable. But as you go from RF at the limiting velocity of the dielectric, 66%, 70, 80, 90, whatever it might be, speed of light, or, speed of light's 100%, so it's going to be something less than that. But it always goes from there down to 0. And it just so happens that it's going down to 0 right through the audio band. So you'll see the velocity of propagation is in the 50% range, and it'll drop down to as low as 10 or even 5% by the time you get to 20 hertz. So you have to kind of look at that and think, that's not very accurate. That's not linear. That's not coherent. My definition of coherent is consistent. So the speed of the signals with respect to frequency is not consistent. And that's what I was trying to root out in these cables, is how can I make all these cables as consistent as I can possibly get them through the audio band. 0 RLNC, in other words, would be the ideal cable, of course, but you can't do that.
How expensive is the equipment that Belden owns to test these wires, these cables?
Oh, geez, it's in the hundreds of thousands of dollars range.
Is it available to everyone?
No, not to the extent of the accuracy that our calibrated units are. No, we have some high-end Hewlett Packard RLC meters. You can get some pretty good stuff made by Keysight. For instance, it'll do RLNC, within reason. I'd say 10%. So you get damn close with the Keysight units and the like. But if you really want the true lab grade stuff, that's not going to be of interest to most people anyway, because you have to keep the lab at a set temperature because resistance changes with temperature. So you have to have a monitor temperature sitting there right by the unit so you know it's really at 20C. If it's not, you have to recalibrate it, all that kind of stuff. So if you really want as close to the right answers you can get, it just gets more and more difficult to do is all.
Is the advantage in Iconoclast the actual construction, or is it a combination of construction and how the wires are braided together?
Well, the joke is physicals equals electricals. And that's the truth. I mean, the physical arrangement of the wires in free space in front of you, held in place by plastics, is what determine the electrical properties of the cable. All right. So you can't really separate the two. They're innately connected to one another. So the math can tell you what you want to achieve to make a, quote, better measuring cable. Doesn't tell you what you can hear, how much better it is. It tells you it's better. How you get the magnetic fields to cooperate to give you the result you calculate, though, isn't a giveaway. That's in the design, and that is up to you to figure out, is how do you get the electromagnetic design to give you 0.08 inductance, for instance, with 48 wires. That's not a freebie. I can say I want 0.08 with 48 wires, fine, but now go get it and come up with design that really does it. And that was part of the problem, is how do you make these cables that are truly, truly, really better measuring? Because I need those wires to do other things that I need to achieve as well. So a cable is sort of a collage of overlapping variables. I need low DCR. I need a lot of wires for this. I need low inductance for that. I can't have high capacitance because of this, so on and so forth. So it's not quite like making a coax cable where you pick a dielectric, pick a conductor, pick a shield, and then say, okay, now most of the problem here is how precisely can I make that coaxial cable as far as dimensional properties. Analog cable actually is way, way, way harder to make than RF cables and even Ethernet cable.
If you were to take a Belden 1313A, a very well-known and endorsed by you speaker cable, common speaker cable in the audio world, right? And you were to compare that to an Iconoclast cable objectively, what is the biggest difference?
The difference is going to be in the current coherence, the velocity of propagation linearity, and of course, lower LNC properties.
Do you believe that that is easily heard?
I won't say easily. Let's assume that you have a system that you can assume is good enough where you can hear a difference, as well as good enough source material. I would say if you're musically inclined and you know the kind of sound you're after and you're kind of an intense listener, most people can pick it out pretty quick. Okay. Definitely they can say, wow, that's different. Now, my wife, for instance, can tell me, yeah, that sounds different than that. And I'd say, okay, which one do you like? And she'd say, well, on that one song, I like that other cable better because this cable makes it sound a little this, that. But on most songs, I still think I like the highs or the way the voices sound on this. She can tell it's different, but remember, what's better is a personal opinion. But that
subjective.
Yeah. But my point was, so you are saying the cable's different. She says, well, yeah, why would I not say that? You can clearly hear the difference because to her, this is not, she sings in a choir. She's not an engineer. She has no reason to, quote, lie.
Right.
And I said, well, the project was to prove cables are different when you make them better or worse, so to speak. And you're hearing a difference here. And she says, oh, certainly. She said, I don't see why this is so weird. And then she walked off. So to us, we're a little loopy in that regard.
Right. Do you believe that that is mainly what people would go after, is that because it sounds different and you include psychoacoustics with all of this, that a lot of people might listen to it, and because it sounds different, they associate different with better, even though that the cable objectively measures better, it doesn't necessarily mean that it sounds better, it just sounds different. And yet they associate different with better.
Sometimes I'd say there's a core of people that don't want to venture away from what they're used to hearing. And when it's sufficiently different from what they're used to, they're kind of taken aback by it. and not in a good way. Usually in well, I don't know if I like this new thing here, because they've been listening to the other for a long, long time. So when I first put them on and listened to them, I was shocked, for instance, at what I heard. And in some ways, I was almost unhappy about it because I was hoping the whole experiment would prove, hey, I've made cables that are decisively better than our other products. And see, you can't hear a difference. Therefore, case closed, buy 1313A, 1694A, move on. It didn't turn out that way. It turned out it's like, oh, God, now I got to tell management, what are we going to do with this? Because their impression was, yeah, go ahead and, figure out how to make cables better because we can do something with that somehow on other products for some reason. Maybe not audio cable, but yeah, just go ahead and see what kind of technology you can come up with to improve RL and C through the analog band. Not expecting that the cables would actually improve. And that's when I basically took the cables to a local audio house and said, hey, when you get some people come in that you think you're really good customers, really good listeners, here's a prototype cable. It's not pretty. It won't sound any different if I make it pretty, but have them listen to this and tell me what they think. And one guy came to my house and was demanding that I sell him that cable. And I'm like, well, why? And he said, this is the best thing I've ever heard in my system. This is unbelievable. This is like a component upgrade. You're going to sell this, right? And I said, well, no, I was just kind of wanting people to verify if they thought it sounded different or not is all. And he said, oh, in a big way. So we kept getting pressure from these, what I'll call early beta testers that, well, Belden's going to sell this, right? And I said, well, Belden's not really selling audio cables. We can sell you the specs, but we can't sell you the sound, okay? Because we're just not into this argument. So, and as a matter of fact, no Belden cable sells you what it sounds like, not even our 1313A. You get specs, right? 20 puff per foot, whatever it is. And that's it. But here we are in this weird universe where all of a sudden we have to sell it by using adjectives. And our marketing department and the like doesn't know how to do that. There's an old joke in engineering department is, well, engineers are engineers and don't ask them for adjectives because they're trained not to lie. You sort of have to deal with the facts, like them or not. Right. But you learn that sometimes bad information is just as good as good information. So after you get used to that in your career, you don't see a failed project as a failure. You just see it as a different set of answers, to be honest with you.
If you were to say, if you took 1313A and Iconoclast, would you say that specification side, objectively, that 1313A would be, say, 95% of what Iconoclast is?
Depends on what attribute you're talking about. Because a cable is a superposition of electrical attributes that you hear. Now, if you were to look at just DCR, for instance, there's no difference between Iconoclast and 1313A, as a for instance. Okay. Sure. But if you look at how DCR is acquired by using one big wire versus 24 small wires, that affects what's called the VP linearity, because the equation requires adjustments to R and C that change the slope of the curve of the VP linearity as it goes through the audio band. You can't get rid of that slope, the characteristic drop from what I call the limiting velocity down to zero. You can only kind of push it around a little bit to be more in your favor in terms of what you want to hear through the frequency range you're interested in. And you do that by adjusting R and C, for instance. So those variables you can adjust. But when you adjust those, it'll change other variables, for instance, that you really don't want to run into. And you also have to realize, am I designing the cable for the speaker or the amplifier? The amplifiers don't like a lot of reactance, for instance, yet the speaker wants to see a very low impedance cable, which requires high reactance, believe it or not, on a cable. So you have that quandary. So if you make an amplifier nonlinear and make it sound bad because it's not linear, are you listening to the cable sounding bad when you put that in your stereo, or are you listening to the amplifier you made sound bad, for instance? So sometimes it's hard to de-embed, which basically means pull the amp out separately, the cable out separately, the speaker out separately, because when you listen to it, it's a network. So you really actually never hear just the cable. You hear what it does with the other two components. And that's why they'll sound different, by the way, depending on what amp and speakers you use, because the damping factor of amps vary depending on what the reactive load is. We don't test them into reactive loads, by the way. Amps are tested into a resistive 8 ohm load, 16 ohm load, 2 ohm load, but that's not how they work. They work into reactive loads, and that makes them much more nonlinear than the test data you see. But we don't know what kind of reactive load to use because they vary all over the map with every single speaker you use them on, right? So they just standardized on, okay, we're going to do it in 8 ohm mode, and we're just going to assume if these numbers are pretty good, that however worse it gets is still not going to be that bad. Therefore, the amplifier is still going to be fundamentally okay sounding. So,
what do you believe is the best way for somebody to pick out a set of cables for their entire stereo, from source to amplifier, amplifier to speakers?
start with your speaker cable first, because you're trying to match the reactive output damping factor of your amp to the reactive input impedance of your speakers. You're going to have the biggest change there 99% of the time. Interconnects not as much, because the advantage of an interconnect cable is it always goes into a theoretically infinite impedance. So the impedance is an open circuit. So every single thing always is going into an open circuit, no matter whose stereo it is, it's going into 47K ohm or higher type input. That gets rid of that variable. So in other words, the load is constant for the most part. The op amp is feeding a little bit of a capacitive load stuck on the end of it, for instance, but it's not feeding into a very reactive load at the other end of the cable. So I'd start with a speaker cable and then work backwards to your interconnects.
And if I start with an interconnect, would you say that a Belden 1800F is suitable for everyone?
No, I mean, it depends again on how good you want it to be. For instance, if I put that 1800F into my head amp and then I replace it with Iconoclast, there's a difference in how it sounds.
Right.
So, but if the difference is not enough for you, then it is good enough. But if you're the kind of person that if you can hear be a little more open sounding, a little faster sounding on, some of especially your worst recordings. That's the funny thing too about this hobby. Really good stuff, believe it or not, doesn't make your good recording sound logarithmically much better. But boy, it really helps your bad stuff.
Why is that?
I think, like, I got a Herman's Hermits best of CD. Stuff sounds like it's coming out of a tin can between your speakers. When you improve that even a little bit, it's like horrendously easier and better to listen to. All right. Now, when I play my Lynette McKinnon albums, they're already good sounding anyway. So yes, they can be a little better, but they already were very listenable. So I think it just pushes stuff to the point to where you now do want to listen to it. It sounds good enough to be enjoyable.
What specific attribute in cables do you think correlates to those examples you just gave me of bringing it out from a tin can?
It's kind of weird to explain, but the smoking gun to me, in terms of what I've looked at and what I've designed to, that I know I'm designing to. Now, someone can come up to me and say, Galen, this cable works wonderfully, but you don't even understand what you're doing, because this is what you really did by accident. And that's happened before. Trust me on that. But in terms of what I cognitively did, and I've had nobody come up to me yet and say I did different. And that's what the papers are out there for, by the way, is peer review, is to say, hey, guys, this is how I'm doing this. Is there something here I'm missing that we could do here to make better audio cables, and maybe come up with some sort of test standard or design principles for audio cables so they really do honestly get designed better from an electrical standpoint. So when a customer buys your cable, they know they're getting specific electrical parameters that may benefit them. Not the sound per se, but the cable definitely is better in these ways because we did this, this, and this. But on Iconoclast, it has to do with the velocity of propagation linearity that I looked at and tried to improve, and that requires the use of multiple small wires and higher DCR wires to achieve. And it makes other attributes really hard to match, by the way. It makes it hard to keep the capacitance down, for instance, and it makes it hard to figure out, well, how am I going to get low inductance with so many daggone wires, running every which way? So you have to come up with some pretty elaborate designs to control those other variables. So,
do you believe that, I presume that you're familiar with an audio analyzer?
Yeah. Mm-hmm.
Yep. Do you believe that if you hook up a set of X cables and then you hook up a Iconoclast and look at the output from said device going into the AP, that you'll see a measurable difference from the output of that device?
it's going to be really small. And that's the aggravating thing about it. You can measure RL and C. And for instance, you can take a cable that's got 0.126 microhenries of inductance. You can take a Iconoclast that's got a measurable 0.08. You can put them on you take a 10-foot piece of cable, you can put them on an auto precision analyzer, and you can try to look at the square wave response, for instance, and try to, quote, see a difference. There's definitely a difference there because you've changed the L and the C. Mathematically, there has to be in terms of what it's doing to the waveform. Yet you don't see it on a test signal, for instance. Now, music's weird in that you only have one voltage at a time on your speaker terminals. It's a superposition of all the frequencies at once being added together concurrently at any specific reference time interval, okay? If I shift those frequencies left to right based on the speed that they're traveling through the cable, that electromagnetic wave, by the time it gets to the end, is theoretically going to superimpose slightly differently and add up different. It's just like cars lined up on an interstate that are nose to nose. That'd be what would be considered your phase. If you put them in perfect phase, all the cars are exactly identical when you start them on the interstate. Group delay is what happens is when one car is going 60, one's going 62, one's going 80. They go down that road a while and pretty soon they're spread out. So if you take a picture of them after so many minutes or miles, you'll see that the signal is now changed. Well, if you add them up at that moment in time, you're going to get a different answer because they've moved, and that's what's called group delay. And that's what changes the imaging that you hear between the speakers, is how that electromagnetic wave is actually comprised at any moment in time. So when you move these frequencies around as you're sending them down the cable, that's going to affect how the cable images in front of you, because that's got to do with phase. That's not frequency response, right? You measure the frequency response of the cable and you'll see that there's basically none. So why do they really sound different? And I think the biggest thing that's affecting that is what our ears hear as the phase shift properties of the cable. And human ears are really sensitive to phase more than anything else. If you scare somebody, the first thing they do is turn in the direction of what scared them, right? They don't care what it is, but it's more important to know where it came from first, what it is second, because I want to run the opposite way from it while they figure out what it was. But it doesn't do you any good to stand there and say, oh, that's a tiger, only not be running yet, and then have it eat you. So humans are really sensitive to directionality and phase characteristics of noises around them every day. Have you ever been in an anechoic chamber where phase is removed?
I have.
You're almost sick, right? It almost makes you sick to your stomach because your brain is saying, I'm scared shitless because I don't know where anything's coming from. This is not normal. You're in danger. And some people will have an adrenaline rush and actually even pass out from it. But that's how dependent we are on phase information. So that's why I kind of think using multiple small wires and paying attention to the velocity linearity in these cables improves the way the sound, is exhibited in front of us. And no cable's perfect because of the way the physics works. You can't really tune your way out of it. It's just, it is what it is. You can make it better. And the way I chose to make it better is I tried to flatten it. You can't speed up the low frequencies. You can only kind of slow down the high frequencies so they time align a little better. So in other words, all the cars are going 60 to 65 to 70 miles an hour. You get rid of the guys that are trying to go 80 and 90, and you try to crowd them in a little bit. And that I think your ears pick up on. Again,
it's small changes, very small.
Oh my God. If you go to websites like Audioholics, I'm sure Gene, his numbers are spot on. Okay. The difference between Gene and I is simple. He doesn't think you can hear anything past a point, and I'm more pragmatic, saying, well, if the cable's definitely better, there are applications where I think you definitely do hear a difference, Gene. That's where we're different. So I don't think we're combative on it at all. But using Gene's site and mine, you'll look at the individual numbers and you'll say 10% of the speed of light is still damn fast, and the cable's only 10 feet long. There's not enough distance there for the signals to get out of phase enough to actually sound, quote, different. Even though they're electromagnetically, they are definitely different because they are changing phase with respect to one another when you add them up. That's the argument, is how sensitive is the ear to that within a given length of cable. Not that it isn't happening, but one guy says, that's not enough to hear. And my experience is hooking them up and using them in my system is saying, unfortunately, I'd love to agree with you, Gene, but I don't, because I can hear when you change, especially the speaker cables. I've heard too many times in too many systems be remarkably different when we put these cables in. So,
and again, when you say different, that's subjective, correct?
well, it has to be. Oh, it has to be subjective. Sure it is. Yeah.
Okay.
Some people like their music warmer sounding. Other people like it a little more fast, vibrant. For instance, more of what I call, you got the horn sound, the classic horn sound, where trumpets and things really sharp, really biting, really fast. And then you got, over here where things are a little more warmer and mellower. And again, stereo is entertainment. It doesn't sound live. It can't sound live. So I hate it when people keep saying the absolute sound, for instance. But baloney. I don't want my stereo to sound like Elton John when I'm in an auditorium. I would never listen to it on purpose. It's an experience when you're there with everybody, but it's not an audio experience per se, because the sound's so messed up. So my wife sings in a choir with a full orchestra, and the only time it sounds good is when she's practicing. And I can sit in the very front, and I'm only 20 feet away from the violins. Then I can hear what they really sound like. But the minute I go to a show and I'm back in the middle with all the people damping all the highs, it sounds like a muddy, weird acoustic mess. It's not. And I would not want my stereo to sound live, for instance, like that. I want it to sound like I'm 10 feet from the instruments,
Right.
in my chair. So take it for what it is. My opinion of high-end audio may conflict with a lot of audiophiles. But I will say, the smaller the ensemble, the more close it can start to sound real. In other words, if you have jazz, well, a lot of people like jazz on high-end. You'll see a lot of high-end stereo people lean towards jazz because it's smaller ensembles, and you can hear a single trumpet, a single voice, maybe one set of drums. A stereo kind of can start to make that sound real. And most jazz ensembles are done in smaller venues anyway, and you sit relatively close. So I think there's a reason for that.
Okay.
But Supertramp in my basement at home, no way. Can't do that.
Have you ever done any research with equipment manufacturers to try to figure out the why and what works best for certain amplifiers?
Well, if you talk to past labs and people like that are good at knowing, first of all, they know amplifiers don't sound the same. Now, remember, the old school of thought too is all the specs on amplifiers are so good that your amplifier, once it gives you the watts you need, don't spend money on that. If you don't need more power, they don't sound different. The hell they don't. I have two amps, really three. One is 2 amps in one. It can be Class A or AB. Then I have another amp that's an AB, classic feedback type design, or what they call the link circuit. It's actually local feedback between each stage. But nonetheless, all three of those amps sound decidedly different playing music. If you look at the test data on them, though, all the test data is the same as cable. There's not anything here, the way they're tested, that says the human ear, at least what people think is the human ear, could test them. So, if you talk to these guys, that there was a challenge. I forget who it was. Daggone it, I should know. I think it was Bob Carver. But he was told, can you make this amp here sound like this amp over here? And he says, yeah, all I got to do is change the parameters on my amp to do it. I don't have to change my amp, mind you. I just have to change the feedback and a few things, and I can make it sound like this completely different design over here, but I can fundamentally match the sound enough where you will say it's the same amp. And they said, we'll do that. And he did it. And they put his amp on and said, holy crap, these amps now sound the same. He says, yeah, I designed my amp, though, to sound the way it does, not like that, because I think an amp to a lot of my customers is better like this. So cable's kind of the same. And that's why I think the market is still viable. Cables will sound different, and you'll have some people that will enjoy one kind of sound over another. Now, I've taken the approach that's kind of dumb to most, which is why I'm probably one of the few that's done it, is to strictly try to design them straight up from the empirical test data and the calculations, period. Nothing. If I can't make RL and C better balanced and make the VP a little more linear and all of that and explain it in terms of what I'm doing, then I won't do it. There's nothing subjective per se, other than okay, I don't want the capacitance to go above 45 because it'll put too much of load on amplifiers and make them nonlinear. I don't want to do that. I don't want to make my cable make amplifiers become nonlinear. I don't think that's a fair way to approach this. There are cables out there, by the way, you can buy today that will raise hell on your amp. They'll have 3,000 picofarads per foot of capacitance. Well, you're not putting a cable on your amplifier anymore. You're hooking it up to a capacitor. It's just a long capacitor. Now, it might have really low inductance, right? Because what's a capacitor? It's something that has low inductance and low resistance. Well, there are cables that literally look like electrical components, not a cable. And those can raise hell on your amp if you're not really careful. So I didn't want to design a product like that. So I had to make sure I kept L and C within reason as well. So, and that makes it harder because you just can't say, oh, I'm going to take a 0.5 mil polyester film and put copper on each side of it and have 0.002 inductance. Oh, but I have 3,000 microfarads of capacitor, here that someone's going to have to deal with. No, that's not really a cable to me. That's a component. So,
do you believe that there will ever be enough research to determine what specific factors in a cable correlate to what we hear?
Yeah, no. I mean, gosh, we've been making these, quote, better cables now the original cables, if you recall, the biggest realization was if you lower the DCR of the cable, it does improve the damping factor of amplifiers, which improves the tightness of the base. That was the original smog lifters from Diskwasher and all those early, quote, high-end audio cables. And they work. I don't know that they knew as much about why they worked then as they do now. And I also know that Diskwashers added lots of capacitance to amps and would actually blow up a lot of amps. I had a phase linear 400 amplifier. It was a very loosely regulated power supply design. And if you put a lot of capacitance on that amp and turn the volume up very much, especially on phono, even with the needle off the record, if you tap the head shell, it would send the amplifier into oscillation fits and all the fuses would blow. And it was from the speaker cable loading and the way the amp behaved because it had a really, really wide bandwidth in the day. If you recall, a lot of those amplifiers had virtually uncontrolled wide bandwidth. Right. Harman Kardon was the worst. They were like RF amps that you just put audio into. So you had to be really careful about what they were amplifying because they would be clipping like the devil and you wouldn't know it because they're amplifying some noise that's way above your threshold of hearing. But hey, at their wideband amps, it's gonna amplify that and it's gonna take up all your power to do it. So it's gonna be clipping before you even start to play music. But the question is, are we gonna really figure out? I don't think so. I think the human ear is so hard to quantify from person to person, let alone on a geometric mean of what we all hear, that it's going to be difficult. I do know that we're very time-based sensitive creatures, way more so than amplitude-based. You can change the volume up and down a little bit, and I don't think that really bothers people too much. But if you change the phase of a signal, people will start to really pick up on that. They'll say, hey, the mid-range is getting really blurry. I can't really hear it. A good example is most movies are mixed in 5.1 sound. And if I listen to it on my system downstairs without a center channel speaker, and in other words, I'm using my regular 2-channel audio, the mid-range is impossible to understand. My wife and I look at each other and say, I can hear him talking, but I can't understand what he's saying. And it's because the mid-range channel is missing and it's out of phase being played in the right and left channels. So it's audible, but you can't understand it. Yet I can hear a gunshot, I can hear the sound effects, I can hear all kinds of things. But when people are talking at 90 dB, I can't understand what they're saying. So it's like, okay, this isn't an amplitude problem here. It's a phase problem with the information that's going through the speaker. You go to the movie theater, same movie, but they have a true 5.1 system with a center channel. No problem at all understanding the audio. But you go home and you think you've lost your hearing. And that's all got to do with the phase properties because it's loud either place. Turning up the volume doesn't really fix it. So,
can the same be said for Ethernet cables and USB cables?
Ethernet cables are interesting. And again, we sell these on the data, right? If you go by the IEEE spec, it'll say you need these attributes to send signal down a cable at 100 megabits a second.
Yep.
Guaranteed it'll work. And it does. The bit error rate is 10 to the minus 13th. It's humongously good. But people will come to Belden and said, we want better than this. We want 350 megahertz bandwidth, not 100. We want 500 megahertz. We want 500. And they keep pushing the performance of these cables well above what the specs say are required. So if you look at Ethernet cables like audio cables, i.e., quote, snake oil, and snake oil, I'm defining that by saying if you have better than what the minimum people feel is necessary, anything above that, let's call it snake oil. It's not really snake oil. It's real. We test it. There's no question it's better, but is it needed in a lot of applications? Same dilemma, I think, that we have with analog cables. But nobody cries wolf on Ethernet cable for 1 second when you have a 600 megahertz DT600D cable and you're putting, 1 gig Ethernet down it. Is it necessary? Most of the time I would say no, especially considering most people aren't going 328 feet. They're going, and the less you go, the less good the cable actually has to be. So you throw that into the equation, and the whole thing, to me, seems just as absurd as buying a superly highly designed audio cable that is demonstratably better. But then there's always the question of how necessary is that for some people.
And that's what I was asking, is if you take an Ethernet cable in somebody's system that is typically a meter, maybe 2, maybe even 3 meters, from an objective standpoint, and I think you just answered the question, it just doesn't make sense, right?
Well, you get the cables too short, and it does, because you can get some really strong reflections back and forth inside the cable at Ethernet frequencies. Fiber optics is really bad about that. With single mode fiber, they'll actually put attenuators in a fiber optic link to absorb the back reflection so they don't go into the transmitter side and screw it up and actually break it, so to speak. Ethernet cables are the same. If they get too short, much less than about 15 meters, for instance, they can, that's called a short reach permanent link. But the shorter it gets, the harder it is to manage back reflections. So you got to be careful sometimes. So sometimes you can actually have a cable that's, quote, too good. In other words, it doesn't attenuate the back reflections like it should.
But wouldn't you say then most people in their home environment use an Ethernet cable that is a couple of meters long from the wall to a USB streamer? And that's going to be the next follow-up question, is about USB cables. But let's stick with Ethernet right now. Is most people use short Ethernet cables. So
well,
is that...
Ethernet auto-negotiates, right? If you think you had 1,000 base T, but you got a lot of back reflections, it'll renegotiate to 100. If that doesn't work, it'll go down to 10. Most people aren't moving enough bandwidth to even notice their system is not working properly, even in 10 megabits a second. I worked at Belden, where we make the best cable available, and my desktop computer network is connecting at 10 megabits a second. Did I ever sense that it was too slow ever, moving big files around to the plants or anywhere? Never. I never had a connection faster than that in reality, because it's always the weakest link in the chain. And whoever I talk to somewhere, even if I had a new computer with 100 megabits a second connection, I would still notice I'm always at 10, 99% of the time, because there's something in the chain that's 10. Well, when you're sitting at home and you're running relatively short length cables in your home network and stuff like that, most people, most of the time, don't even reach back around their computer and look at those LEDs to see what their connect speed really is half the time. And usually it's around 100, 10 and 100. Very rarely will you get a true 1 gig stable connection with the links that short.
So do you think that it sonically will change the way a stereo can sound because the Ethernet cable is too short going to your USB streamer?
No, as long as the bit error rate can hang in there and error correct, 10 to the minus 13, the cable, remember, is just converting zeros and ones, and it's re-triggering it. Now, when you do your D to A, when you take those zeros and ones and you run it through a filter, the filters have a tremendous impact on what the analog output looks like. You can go to Stereo Review and look at DACs all day long, and some DACs even have 5 or 6 filters you can pick from that have decidedly different roll-off characteristics. And of course, the ringing characteristics will be very different on those filters. You'll have some will have a big bunch of pre-ringing, some will have post-ringing, some will have half of each. No matter what you do to it, though, you always have to deal with what's called the filter's ringing and roll-off characteristics. The cable doesn't do that, though. It's the D to A and A to D that's doing that. And that's why I say that I don't think the cable on digital is as significant as people want it to be. I haven't heard it in my system, in my basement, and I built a crappy streamer on purpose. I have an 10-year-old Intel i7 3770 CPU, Windows 10 PC with a 6 terabyte Seagate NAS drive on it. I stream into a power line over or Ethernet over power line wall wart. Okay, imagine. So I'm putting my signal over house wiring and it's going upstairs. My plug and play control software is talking to the computer through that, and then it's streaming it onto the Ethernet wall, and then my PS Audio DAC is pulling the signal off of that. I'm not even going directly into my PS Audio DAC from the computer. It's going all into the Ethernet, Ethernet over power line adapter.
Right.
And that's running at maybe 20 megabits a second, somewhere in there, but it's plenty fast for streaming music.
Right.
And I listen to that all day long. And the biggest change I hear is when I switch from Yale operating firmware to Torres, on up the line. So that had a massive improvement in how my DAC sounded. But did I change my streaming software any at all? Nope. Still the same. So I think it's the filtering that is the biggest gorilla in the room by far.
Blue Jeans sells Ethernet cables that are tested before shipping, correct?
Oh, yeah. And that is important, too. If you really, truly want to try to get it to connect at the proper speed, they do need to meet the requirements to do it.
Do most cables that you buy, most patch cords that are Ethernet patch cords, do they meet the spec?
No.
Why is that?
They don't need to sell. That's why you buy the stuff from China at Walmart. Who's going to police that? They aren't UL listed for the most part because they're used inside your walls where the UL listing generally is pretty lax. All right. They will require you to use UL listed stuff in a building. For instance, if you're building a house, your electrical inspector won't allow you to put stuff in the wall that's not safe and so on and so forth. But no, you see these cheap knockoffs all the time, or you see cable that could pass, but with very poor termination technology that screws it up. The termination is the worst aspect of the cable, by the way. So a lot of the cable could conceivably pass if the connectors are good enough. But since they don't test them and don't, and again, they know it'll auto negotiate down to 10 megabits a second. So they're fine with it. Oxford University, where I live here, they use bonded pair DT350. They don't use it for 350 megahertz of bandwidth. They use it because the pairs are bonded, so the impedance is super stable, and the manufactured assemblies we sell them are super consistent. So when kids have problems in their dorm room with their computers, the first thing they tell them is, we're not going to come to your room until you put in the cable we gave you and get rid of the thing that was in the box that came with your XYZ. 99% of the time, they say when they switch the patch cable over to a well-designed patch, it works because they know the permanent link between that room and the computer is fine. It's been that way for years. They just change kids from one year to the next. So what changed? The patch cable changed.
Right.
So
do you believe that USB cables have basically the same effect with the Ethernet cables, that they don't really matter as well as long as they're a properly designed cable?
They can. The problem with USB cables, remember, is they have power and signal both on them, and that's a little different situation sometimes on the USBs. So I'm not completely sold that the eye pattern characteristics on USBs I've seen change based on how they're powered simultaneously with doing an eye pattern test. So there can be noise that will decrease the eye pattern, but is the decrease in the eye pattern sufficient to throw the error correction at a tizzy to where it starts making errors? That's what I don't have I don't have a line in the sand that says, okay, when the eye pattern decreases to this, due to the power manipulation and the cable or the interference, we have a problem, for instance.
Would you agree that using a properly designed DAC is more important than using a boutique USB cable?
Oh my God, yeah. To say the PS Audio DAC is not important and my cable is what I'm hearing, I would say that would be the flip side of what I think would be an accurate statement. Yeah.
So having a DAC that is really good at filtering that input at the USB, for instance, would eliminate the potential of a subpar USB cable. And I mean subpar cable being your average gold right? Belden Gold, I believe it is. Is that?
Well, they use a bonded pair technology in the USBs, all right, which again has very tightly controlled impedance because the two wires are connected intimately together. And of course, like I said, your electricals are strictly determined by the electromagnetic geometry in the cable. So the more you can fix that in place, the more you know what the electricals of the cable is along the length. So yeah, the better you can get that to be, the better the cable's gonna, behave. But to say that somehow the cable is what you're hearing and the DAC isn't, just look at, well, what does the firmware do between Yale and Torres, and what's the current one now? I can't remember. I'm on a third one yet on my PS Audio DAC, but they're decidedly different sounding, and it's got to do with the filtering technology that Ted Smith has decided is, quote, more, better at taking the digital signal and matching it to the analog that it should see on the other end. So, and it's a bunch of math. And he looks at the input and he looks at the output and he makes all these adjustments. And he may decide, well, it sounds better if I'm more accurate in the middle than at the bottom or the very top. So I'm going to make this firmware bias more towards being accurate in the middle, for instance. And it can't be accurate everywhere because it's an approximation based on frequency, because that's the problem with all analog circuits is they're nonlinear. So you have to make a judgment.
And you do agree that there are other DACs that accomplish that as well. Not only, okay.
No. My God, no. God, there's all kind of filters and things on DACs. And I'm not to say that I couldn't listen to 10 DACs and find one or two that I like better than the PS Audio. It's just that I can afford the PS Audio, and I think it's a really good value. We're all stuck with that, right? You have to decide, okay, what can I afford? What are the DACs in this price range? What actually has a bridge that I can plug into it and stream into it? Those kinds of things. So there's other requirements to enter into what you use and why you use it. Obviously, I could probably go to anybody and try to get a DAC, but I think Paul's stuff is nice. I think his DAC sounds really well. I will be honest, I wasn't as thrilled with it with the Yale operating system on it. And it wasn't that I didn't know I wasn't thrilled with it. It was that I chose to listen to records if I wanted my stereo to sound really good. As he improved the firmware on it, all of a sudden, it doesn't matter anymore if I listen to digital or records. I enjoy it just as much. Slightly different sound, but I can't say I enjoy one over the other anymore. That was a big change. So from that end, my digital now sounds good. I can actually say I think my digital is good. And it doesn't matter if I'm streaming from my computer or if I streamed off of Quabits. I'm sure if I use the same bit depth files, I would be equally happy with it.
Yeah. And I appreciate that. I'm just trying to make sure that we're clear that you're not saying that a PS Audio DAC is the only DAC that will do it well. That's all. There's a lot of DACs out there, and there's a lot of DACs that audiosciencereview.com has even measured that are exceptional for a very reasonable price, right? And that is more critical than anything, that the input and the output are properly designed, right?
Absolutely. I can't agree with that more. I think it's the A to D and the D to A filtering technology that is what our ears have to be hearing. Now, obviously, a direct stream DAC uses a different reconstruction filter. For instance, it's more like SACD that some people claim is naturally more linear, but it's hell bent for harder to make because it has to be really high bandwidth, and all of that other stuff that goes right along with it.
Right.
So the concept seems good, but the execution is really tough. And it took Ted 3 or 4 firmware revisions, I think, to make the quote right compromises where this thing really fully saw its potential. The potential was in the hardware, but he had to change the software to get it out of it. And that was tough.
Have I not asked you anything that I should have? Is there anything that you'd like to tell the listeners?
Well, I mean, some people always joke about the name. And I'm like, well, the name wasn't mine. I said, I was in a test lab. And one of our test engineers was testing one of the early cables. And he came to my desk and he says, Galen, we can't test your cable today. The LRC meter's screwed up. And Carl, one of the head testers, was there. And says, what do you mean? And he says, well, I'm not getting the right capacitance on it. It's way off. Something's wrong with it. Carl said, well, did you test the reference piece? And he says, well, it's far enough off. I know it's broke. I don't need to test that. And Carl, you have to understand Carl. Carl is the measurement engineer's engineer because nothing ruffles him whatsoever. He always follows the procedure no matter what. He is totally motionless. So he said, well, let's go measure the reference sample. So Dave looks at me and he rolls his eyes as though, okay, Carl's crazy. He has been down this road with him before, until you get him to say, okay, I guess it is broke. So he said, all right, well, I'll go back with Carl and he can show that it's broke and we'll get it fixed. So we go back and Carl comes back and says, no, Galen, everything's fine. The number David has is perfectly right. And I go back to talk to David and he's sitting there looking at the cable and I said, what's the matter? And he says, Galen, this thing has 48 wires in it. This thing should be 400 picofarads per foot. It's 20 freaking 5. What did you do? And then he says, this cable's iconoclastic. And then I looked at him and said, David, you just named our product line. So that's how it got the name, it was totally past what his belief system allowed him to believe. And even though he knew it was right, he still didn't believe it. And he tested it for a week, trying to find out what was wrong with it and how to make it test 300 puff or more. Because he said, that's where it has to be. There's no way this cable could be testing that low. So I explained to him what I had done. And he was duly impressed, which is, strictly from an engineering standpoint. Carl wasn't, because he said, well, yeah, that makes sense if you did this and this, But again, Carl was, right in there. But I said, well, this was part of the project of trying to make a cable truly better. And he says, well, I can't say you didn't do it on this. He said, this is amazing. So I kind of explained the technology to David as far as what it was doing and why.
Right.
So that's kind of how the product line ended up being named. Now, the Series 2 and the interconnect, that is just an extension of what I know has to be done to make a cable better. And that the Series 2 cable uses 4 30-gauge wires in it to raise the resistance instead of one 25-gauge wire, and the RCA and the XLR both. What that does is it improves the VP linearity by increasing the resistance. And it also took advantage of the slightly higher capacitance, because when I use 4 wires, I'm creating more of a capacitor inside there. So the capacitance is going to go up. It just so happens that R and C are in the numerator of the equation, so you don't mind the capacitance going up. It actually worked in my favor. But you don't want it to go up so much that the voltage transfer function of an interconnect cable is interfered with. But fundamentally, with our cables, people think cables are first-order filter and it rolls off the highs. No, that first-order filter frequency is out in the many megahertz, gigahertz almost region. So don't have to worry about that. What you have to worry about it is the amount of capacitance you're loading the output amplifier with. Because remember, your interconnect cable is still being driven by an op amp, and it still can oscillate if you put too much capacitance on it. All amplifiers will oscillate if you put enough capacitance on them. Right. And if you look at like what's called Bode plots and poles and all of that, it can mathematically tell you when an amplifier can no longer have the open loop bandwidth be stable and they oscillate. So you want to keep the total loading low, and that's why you want to keep capacitance on these things low, not because it's rolling off the high, so to speak. That's not really true. I know for some reason people say that, but that's not really what happens. So
gotcha.
And that improves the cable. But again, it's just sticking with the fundamentals that we know make cables better, and that's it. And if somebody can come along and say, I would do this instead of that, maybe that's really what will make it better. I'm all for it. As long as it's legitimate and as long as you can prove in a calculation or design, it's something that you might be able to do. And, if it's better, it has a chance of sounding better. Right. If it's truly made that way. Yep. I just have a beef with cable that offer no data whatsoever as to what are you doing? Why are you doing it? Where are you going? There's a lot of products like that. So we get a little graph from not being romantic enough, if that makes any sense. Yeah. But we're not. So
I get it. Galen, thank you so much for your time. If anybody has any questions, by all means, they can go to www.iconoclastcable.com, and I'm sure they will get you in touch with Galen. Thank you so much, and I'll put links below. Please make sure to subscribe and ring the bell notification. Thank you, Galen.
Bye-bye. Thank you.
Thanks for listening. Find us on YouTube and Facebook at the Intellectual People Podcast and online at theintellectualpeoplepodcast.com. Check back for exciting new episodes.